Okay, welcome back. What we want to look at is continue with Unit 3 or 4. And let me just go up to show you what we're looking at. Level 3 NVQ Diploma in Installing Electrotechnical Systems and Equipment, etc. etc. Now here we're looking at, you can read this for yourself already, okay? Don't need me to read that to you, okay? A lot of this now is constant, okay? Now, outcome 3, understanding the principles for selecting cables and circuit protection devices. Now, this is important because we need to be able to ensure that the protective devices that we select will protect the cable from overcurrent or overload, and will operate the protective device before any damage can be done to the cable. Okay, and here we are looking at session, let me just bring it up on screen, session 9, cable calculations. Okay, and I'll just come back a bit. Okay, good. Now, learning outcome come for this session, okay? And the student will be able to gain an understanding of cable calculations. Okay. And here we have cables. Okay. Right. Now P equals I squared R. Now we know P is power, okay, already, because you are level 3 now, so that should be commonplace. Any cable that carries current will heat up, okay? Now the problem here is to ensure that the cable doesn't get to a point where it begins to overheat and becomes a massive danger, such as here, okay? That's what could happen if cables are overloaded. Okay. Now all conductors have resistance. How do we manage the effect of the heat generated within the cables? And that is what we're going to be looking at. Right, sorry about that. Right, heat is your enemy. Cables heating up or getting hot is your enemy, so you have to treat it as such. Okay. Now, can I also remind you that all this work is 5357, level 3, okay? Let me just go back a little bit just to make sure that I can highlight this to you, that this is level 3 work, okay? Right, now here it is level 3, okay? And you're looking at NVQ level 3. It is reference to unit 5357, okay? Now, okay, thank you. Let's just go back a bit now. Okay. And now it was here. Okay. Now let me just pick it up from there. Okay, again, this is in reference for work 5357. Okay. And let's look at this now. Cable calculations. We carry out the cable calculation to ensure the following. The cable doesn't heat up beyond what the installation will manage. This is managed by various factors. These factors are grouping, ambient temperature above or below 30 degrees Celsius, thermal insulation, use of BS3036 when the cable can overload, that sufficient voltage will be available to drive the connected load. Volt drop must be limited. The volt drop for the whole of the installation is limited to certain values. These values range from 3% to 8% depending on the nature of the load and type of supply source. Ensure that the cable can withstand any heating and magnetic effects from a fault occurring. This is managed by determining the level of fault current and how long it exists, for checking that thermal withstand and shock protection levels are appropriate. Now, I'm going to bring this in close so you can read this for yourselves, okay, in full. Okay. Okay, now just pan out, just make sure we can get it all in, okay. Okay. Now let's look at the calculation process. Calculation process. Now, the calculation process is always the same. There may be variations, but even when dealing with the variation, the order in which we operate never varies. Determine the design current, IB. For single phase AC, IB equals P over V. For three-phase circuits, IB equals P over square root of 3 times V. Okay. Determine the rating of the protected device, IN, the next size up from the design current. We must ensure that IN is greater than or equal to IB. Yes, will be greater than or equal to IB, but it should be greater than IB because obviously IB needs to operate in regards to protective device operate before IN. Okay, let me just make sure we get this in. Okay. Right, calculation process continues, okay? Determine the correction factors, grouping CG, ambient temperature CA, thermal installation CI, depth of burial CD, thermal resistivity of the soil CS, BS3036 fuse when used as an overload device CF. Ascertain the installation method from table 4A2 from appendix 4 of BS7671. Now remember that the 18th edition of the IE regs has come out, and you will need to make sure that these references are still applicable, or you look for your calculations of process. Okay, and it's in your IEE BS7671 or your on-site guide, your OSG. Now again, here we have calculation process continues. Okay, we are not finished with that yet. So determine the current carrying capacity of the cable, IT. This takes into account the ability of the cable to manage the heat it generates. So let's start correctly. My apologies. IT equals IN over CA times CG times CI times CF times CD times CS. And all that is divided, IN is divided by all this, okay? We must ensure that IT is greater than or equal to IN, and IN is equal to or greater than IB for overload conditions. Where we are only concerned with short circuit conditions, then this does not apply in the same way, as we are not concerned with the cable heating up for a long period of time. Take a look at regulations 433.1.1. Make sure that you're looking at the correct regulations in regards to the new 18th edition or any future editions that may come out. Okay. Okay. And again, calculation process continues. Okay. Choose an appropriate size of cable from the tables in Appendix 4 of BS7671. Make sure these tables are still correct and related. I've checked this and they were the last time I looked, but you don't know. Things can change overnight, surprisingly. Determine the volt drop using data from the tables in Appendix 4 of BS7671. Determine the thermal withstand and shock protection. When doing any cable calculations, it's always worth doing a thumbnail sketch. So that is our thumbnail sketch, okay, of what we would want to be doing and what we intend to get done. Okay, let's go up, make sure there's nothing missing. Okay, in any cable calculations, the process is all important. Do not try to take a shortcut. Shortcuts are not in your best interest. Safety, safety, safety. Now here we're giving you an example, okay? Purely as an example, right? So we're saying here now that we have power P, design current IB equal to P over V. P is 3000 watts, V or U, please note I am more fashion, so I will still tend to use V. P over V, U is 230 volts, equals 13 amps. Now, here we can now have a protective device of iron equals 15 amps. Current carrying capacity of the cable IT equals 1 IB over rating factors. And here you have IT equals IB over CA times CG equals 13 over 0.80 times 1.03. And again, gives us 15.7 amps. Now from table 4D5, column 6, tabulated current carrying capacity, 1mm cable carries 16 amps. So we know that 1mm cable carries 16 amps over the distance. Now for the voltage drop in the cable, look in column 8 of table 4D5. Volt drop equals millivolt amps for over M times IB times length. Volt drop equals 44 times 10 to the minus 3 times 13 times 15 equals 8.58 volts. And that's giving us a volt drop of 8.58 volts. Now again, remember to look up this information for yourselves. This is purely an example, okay? And you'll notice here that we've used the power in the circuit that's going to be in the circuit rather than the current, because the power is what causes the heating effect of the cables. Now if the voltage dropped is greater than 3% of the supply voltage for lighting circuits or 5% for other circuits, we need to look at increasing the size of the cable. For a 230 volt supply, a 3% volt drop would be 6.9 volts and a 5% voltage drop would be 11.5 volts. In our example, we are well within the permitted 5% limit. And again, confirm that we are allowed 5% voltage drop for lighting circuits. So for me in this case here, because we have a voltage drop of, if the voltage drop is greater than 3% of the supply voltage for lighting circuits or 5% for other circuits, we need to look at increasing the size of the cable. For a 240 volt supply, a 3% voltage drop would be 6.9 volts. And a 5% voltage drop would be 11.5 volts. Now for me, in this case, I would be using 1.5 mil. Okay, that would ensure that we are well within our 3% at least voltage drop. Okay. Okay. Now again, you must refer to the IE regs at all times, irrespective whether it is the 18th edition or advanced from that in the future. Use the IE regs. Make sure you comply with it at all point in times. Okay, thank you. Now, multiple choice questions. Now, get these done for me, please, as well. Okay. Okay. Make sure we get everything in. Okay. In frame. Okay. Okay. Thank you. I hope you found this useful. Okay. And I will continue with the next session. Now again, remember that this applies to NVQ Sitting Guilds 5357, previously the 2357 course. Okay. You will not do this in 5 minutes or a day. Okay, thank you. Sorry about that.